Okay, a quick walkthrough of the Unit 4 participation activities for this week. We're going to be looking at two different supervised learning methods, Bayes networks and k-nearest neighbors, and you'll be posting some answers or some things to the discussion group. There's no responses, so this is all due on Sunday. So first, let's look at Bayes network and the spam email calculation. So we talked about this in the overview of the whole course. I'm not going to go into too much detail. You should watch that video if you haven't already. But again, remember, you're trying to classify emails as spam, bad emails, or ham, good emails. We have a whole bunch of really short one-sentence emails, and we know they're spam or ham, and we know the probability of how often spam email occurs and how often ham email occurs. And then we count all the words. We just count all the words here, all the words in the spam emails, all the words in the ham emails, and create a list. So, given a word, given a word, and that or given spam, we can calculate how likely it is that a word appears in a spam email. So like link appears 2 out of the 9 spam words. So 2/9 of the time it is. So we can calculate what's the probability of the word link being a word. So given any word in a spam email, we can calculate the probability of link being that word if it's a spam. And same here, we can calculate how frequently different words, so like sports appears a lot in these ham email messages. So we can calculate that, and then we have this Bayes formula where this is what we want to do. Given a word in an email, we want to calculate what's the probability of it being spam or ham, spam in this case. So if sports is in the message, and if we look at the data, sports is mainly in the good emails and not very often in bad emails, although we have more good emails than bad emails, so it's not entirely obvious, but it looks to be that this will be a small probability. So you want to calculate that, and then you just plug into the formula these values that we have here and up here. And then just post your answer, check to make sure you're getting the same answer as everyone else. Everyone should be getting the same answer. And if not, work with post some questions of other, make sure you're getting the right answer here. So that's this first part. Then we're going to move on to this k-nearest neighbor area. And so you can download the zip file. It's just right down here is this zip file, or grab it from GitHub using this link. And then you can open that up in NetBeans or Eclipse and run it. Let's just walk through the code real quick. So it's really a short program. K-nearest neighbor is really a simple algorithm. So we have a bunch of known data points here. We have an array of these data point objects, and we create a whole bunch of these. Here we're measuring the height and the circumference of plants, and we know they're either trees or bushes. That's our complicated categories. So trees tend to be tall and have a large circumference. Bushes tend to be a little shorter and have a smaller circumference. In fact, if we were to plot these out, these trees and these bushes, you could see the trees, if we look at the height versus the circumference, the trees are over here and the bushes are over here. So if we have some new unknown data points here like 30, 20, that's most likely a tree, we think, and then 20, 14 is more likely a bush. So we can actually run those. Let's type in 3020 into our algorithm. So we'll walk through this first. So we have all these data points, and again, we're just using a simple data structure with an two parameters and then a type, and then we just have some constructors and some distance calculation. We're using something called Euclidean Distance, squaring the differences and taking the square root of that for this. So this is just a simple data point structure. And then, so we set up all of our data points, our known data points, and we then ask the user to enter new height and circumference, create a new data point, and then we just go, first we're going to print out, we calculate the distance to all the data points there, and then we find the nearest distance. So we just loop through, keeping track of what's the nearest data point, and then based on the nearest point, we classify this object. So again, let's look at this data point here, height of 30, circumference of 20. So if we run our program, Okay, so the height is 30 and the circumference is 20. It'll calculate the distance to all the other data points out there. One of them is very close, and that's a tree. And we can actually see that from the graph. It'll calculate the distance to this data point, that data point, all of these data points it's calculating. So it's just the x value minus squared minus the y value squared, square root of that distance here. And again, this is going to be the nearest data point. And so it'll find that distance is the shorter, the least minimum is, and that's a tree. So it'll say my best guess is that this is a tree. So that's all this method does. So what do you have to do? So you need to, let me get back down here. So run the program. Enter another plant. Pick whatever height and circumference you want, and figure out how that classifies that in the discussion area. So just put your plant's dimensions and then how it's classified. So number one. Then I want you to look at all the 6 distances and find. So we were just looking at the minimum distance here. The shortest, but often we use what is called k nearest neighbors. So we might look at the 3 nearest neighbors. So if we have a data point here, what are the 3 nearest neighbors? And if all 3 neighbors voted, what would this be? So if I looked at the 3 nearest neighbors, this is a 1, this is a 1. These are actually 3 nearest neighbors, and they all agree that it's a tree. But even if only 2 of them thought it was a tree and 1 thought it was a bush, we would still do a little vote, and we would vote, and 2 out of 3 would think it's a tree, so we'd try a tree. So again, we look at the 3 closest neighbors. So in your method, you want to pick some point out there and look at the 3 nearest neighbors, and is that classification the same as the 1 nearest neighbor, which is what the algorithm does. Okay, so post your findings there to your discussion point. So you've got a couple things you're posting all together here, and then finally look at what would have to be changed if you were to change something in the code. There's 6 things to look at. What if you had more data points here? So rather than just these 6, what if you had 100? How would you have to change the program? In particular, if you wanted to read those in from a data file, what would you have to do? Just a pseudocode for that. Now, what if our data had 3 values? So rather than just the height and the circumference, what if we had the leaf size as a data point or something like that? So what would you have to change to your algorithm here and here if you wanted to have 3 data points, not just an x and y, maybe x, y, z? Or what if you wanted to have, 4 or 5, maybe 10 different data points like we had in the spreadsheet example we looked at? We had 12 different measurements for each object. So how would the code have to change there? And again, you just pick one of these 3 things to talk about. Last thing is that right now it finds the nearest neighbor. What if we wanted to implement the 3 nearest neighbors method and have 3 nearest neighbors all vote on what it should be? How would you have to change the code to do that? And one hint is that, remember, maybe you can sort your array. Okay, so post this stuff to the discussion area by Sunday time. One thing is, when you're posting these changes, if you want to, you can also read someone else's suggestion and post more descriptions on those if you want. Okay, so that's a walkthrough of the participation activity for the week.